Today I want to talk about a couple different things. First, I want to introduce you guys to my new dependency injection framework for Kotlin called Injector. After that, we will dive into a few more advanced topics of its usage. And finally, I will try to demystify how it actually works, so you don't need to be afraid of using it in your apps. Well, you're probably familiar with notorious coffee maker example. We have a coffee maker. It depends on heater and a pump, where heater and the pump are actually interfaces, and we have specific implementations for those. One complexity that exists here is that the pump implementation actually also depends on the heater, so coffee maker and the pump somehow need to reuse the same instance of the heater. As I mentioned before, dependency injection is a technique. That means you can implement dependency injection manually. And in case of our coffee maker, it will look something like this. So in this particular example, it maybe not that scary to do manual injection because our class hierarchy is pretty small. But in real world, class hierarchy could be really gigantic, and creating those classes could be super problematic. That's why we have dependency injection libraries. Today I want to introduce you to my new dependency injection library that I wrote for Kotlin called Injector. And to be completely honest with you, it's actually not a dependency injection library. So what is the controversy about the naming? Controversy here is that my injection library actually implement a pattern called a service locator. And the big difference between service locator and pure dependency injection that with dependency injection, injected classes don't have a reference to injector, while with service locator, injected classes has a reference to the service locator. And this is a pretty hot topic of debate in Java and I guess Kotlin community if service locator is bad or not. But I strongly recommend you to read a very old article by Martin Fowler. It was written more than 10 years ago, and it's still relevant. And reading it will help you kind of get an educated opinion on the subject rather than just believing if dependency injection is good or service locator is good. The primary thing you need to understand is that they both are trying to solve similar problems. But there is this small detail that kind of is important to note when we talk about terminology. So this is again our coffee maker with manual injection. Let's see how we can do dependency injection with injector library. So as you can see, when we use injector library, we no longer need to know the details how coffee maker is created. We just ask injector framework, please inject the instance of coffee maker to our field. And one important detail here that any class that will use injector will have to implement an interface called injectable, which is simply a getter that could return you an instance of injector. So at the root of your application, you usually need to at the root, you usually need to create that injector, and later on you can pass it automatically to different classes that you inject to. So how does injector actually resolve dependencies? So probably a lot of you who are familiar with dependency injection, this configuration is happening in classes called modules. So here I have a couple modules. One module for our coffee maker that specify how the pump instance need to be created and the coffee maker itself. The important detail in the second module is that for the heater, we actually specify a scope. So when you specify a scope, it means that when we will try to resolve a heater, we will cache it for the existence of that scope. So while that scope is active, injector will keep returning the same instance of the heater. And the last line is basically how you supply your modules to injector. Injector right now is using kind of, I would call it like a monograph technique, when you create your injector very early on and supply all existing modules. The reason why it's possible and won't hurt performance that everything that injector will do going forward is actually lazy. And for addressing the instance management, we will use scopes that I will cover on the next slide. So here are two unit tests that kind of illustrate how scopes work. So let's say you want to maintain instance of a class called user settings for the lifetime while the user is logged in. So when user is logged in, you ask injector to start user scope. And starting from that moment, every time you will request user settings, you will keep getting the same instance of user settings. But if user will log out and the user scope will be stopped and the new user will log in, you will get a new instance of the user settings. That's basically how you manage all your instances with, all your singleton instances with a specific lifetime coupled to your business logic. The important addition to configuration is that every class that is scoped can also be scope aware. So let's say when you log out, you want to clean up some expensive resource that user settings class have used. So in this case, you can implement scoped interface. So when the scope is destroyed, you can invoke some, let's say, database cleanup or something. And another thing that is really important to follow when you're using scopes is to always make sure that you don't have illegal scope access. So for that purpose, injector allows you to subscribe on injection logs. And every time somebody will try to request a scoped instance while the scope is not actually active, I will record a warning. And in your applications, you should never allow never allow developers to have those warnings in your production code. So if in the development you realize that injector is giving you warnings, you should definitely fix it before shipping any code to production. Another important part of injection is to be always sure that your configuration is complete. So for that purpose, different frameworks use different approaches. Some try to validate correctness of configuration in runtime. For example, Dagger to do it during the compilation time. With my framework, I decided to take an approach where I can move these checks to a separate test. And you actually don't need to write any custom test. You just need to invoke check injector method in a single, basically, unit test, which is technically is an integration test. And if your injector configuration is incorrect, it will give you errors. So in this example, first I have a correct configuration for our coffee maker, so we don't have any errors. And in second test, I removed the heater module from the configuration, so we no longer can resolve coffee maker, or the pump class. And as we talked before, very early, the important use case for dependency injection is actually unit testing of your classes. So how do you test injected class? So the preferred method of injection is field injection. The reason for it is that we want every dependencies to be instantiated lazily. That's why as a constructor parameter, you only usually pass injector itself. So how can you test your class behavior if the only thing you pass to constructor is injector? So to address that, framework comes with a mock version of injector. So with mock version of injector, you can easily specify which fake implementations do you want to have within your test. So in this particular example, I set up a mock implementation for pump and heater. So when I test coffee maker brew method, I can validate that heater and pump are properly invoked. Cool. So now you got familiar how to use dependency injection library, and I want to cover more like how does it actually work. So so we would demystify it, and you kind of will feel safe about using it, hopefully. So let's start with the inject. What is actually happening behind the scenes? So inject is actually an inline function, and the inline functions during the compilations are transformed to an expanded version of it, which will be an inject with a predicate that trying to access injector and get coffee maker instance out of it. And for those of you who are familiar with Kotlin, you can guess that inject is a delegated property. So if we will try to kind of transform it how the final code will look like, it will be actually broken down to a getter and some private field associated with it. So every time you call a coffee maker getter, we will try to get an instance of injected class from injector and cache it in that field. So every subsequent calls to that getter will return you a cached instance. Now let's do the same exercise for bind method. So similar technique here. Bind is actually an inline function, and the full version of it will look like bind call, then we supply our class name, and then we supply a factory method to resolve the instance. And then in addition to that, we can specify that this particular binding needs to be scoped. So basically, module provides you a set of those bindings, and then later on when you put them to injector, bindings are transformed to providers. So the difference between binding and provider is that provider is a specific factory that knows if the instance have to be resolved over and over again, or if the instance have to be cached by the scope. Cool. So hopefully now you understand the internals better, and I want to summarize some design aspects of injector library. One of the first principles that I put in place is I wanted to embrace power of Kotlin and avoid any usage of either reflection or code generation that was previously required with Java to achieve a beautiful API for injection. The second aspect is that I want all dependencies to be injected lazily. So this kind of a learning that I got from like my past experience working at Lyft and my new experience working at Facebook. When you up grows and you have thousands of classes, it becomes extremely important to lazily instantiate those classes to keep maintaining fast cold start. And another important aspect is that historically I saw that scope management was always confusing and too complicated for engineers. So with design of my library, I want to make it as simple, as straightforward as possible. So maybe it will be limiting in certain use cases, but like based on my experience, I could easily imagine that those edge cases can be worked around with the current scope module that was introduced. Yeah, and finally, the very important part is that our injector configuration should be always correct. I think Dagger 2 does a very good job with it, but with Dagger 1, I remember that majority of our modules were declared as library and as incomplete. So as a result, we couldn't really validate the consistency of our dependency graph. Cool, that's it. And I'm happy to answer your questions. So the question is, how does the library compare to, I assume, other Kotlin libraries like Kotlin or Coin? So it actually uses a very similar principles. I would say at this moment it's mostly close to Coin, because in Coin they kind of also encourage you to have a kind of mono injector that you instantiate at the start of the app. The one aspect that I want to change is that I feel like both Coin and Kotlin, they like extensively trying to expand their APIs. And I think this is a huge problem for dependency injection library. Like now, if you will look at Dagger 2, it has like so many different extensions for Android. And people actually, over time, like get confused and they lose their primary idea what dependency injection is about. So with this library, I wanted to keep the API very minimal, very like close to the core of dependency injection. So you don't get like any extra features that could complicate the final use case. Good question. So do I support scope hierarchy in injector? I don't support it right now, but that's something that could be easily added, and I could consider that. Like in the past, we had like solution that maintains scope hierarchy, and it's pretty easy to support it. So the question is, what dependency injection experience I have in the past? Like I used to work at Lyft for more than 6 years. Now I work at Instagram. So back at Lyft, we were for a long amount of time we were using Dagger 1. With Dagger 1, I kind of mentioned that our primary problem was that majority of our modules was configured as library and incomplete. That's why we couldn't do the full graph validation. So right now, Lyft is actively migrating code to Dagger 2. My personal opinion about Dagger 2 is that right now, like, it kind of gives people too many options, and those options are rapidly expanding. You have, for example, you can approach your component from two different angles. You can have components with dependencies, and you can have subcomponents. And then, it's really hard for like regular engineers to wrap their head around that, and they constantly making those mistakes. And now it's even getting worse because we have all those Dagger Android extensions that keep the confusion growing. So at Instagram, we actually are still doing manual injection, and that's partially why I'm like, as a member of our infra team, I'm trying to explore like different ways to do dependency injection and kind of like weigh pros and cons. So that's why I spend some of my free time to like learn more about Kotlin and like figure out how we can do things differently.